Okay, we had 2 cases to go when we ran out of time today. So we were doing 5 cases for converging mirrors. We had done case 1, which was beyond C, and the image was real inverted smaller and between F and C. We did the object at F, and the image was real inverted the same size and at C. We did the object between C and F here, and the image ended up being real inverted larger and beyond C. And so now the case 4 is object at F, and I don't have it labeled because it's sitting on it, but this is F. So because the object is at F, you're not going to be able to use the ray going in through F. But you can use the ray, so with your color from the top, and I think today I was using pink, so this is pink, you're going to go in parallel to the principal axis, honest, that's pink. And you're going to come out through F. Okay, in parallel to the principal axis, out through F. That's one ray. And the second ray with the same color from the top, in through C and out through C. So hitting the top. Okay, so going in, whoops, should never redraw to try to make it thicker because then you just go off the line, and coming out. If you look, these 2 lines, where are they going to cross? They aren't, they're parallel. Even if you go backward here, they are still going to be parallel and are never going to cross. Okay, but wait, we should do the bottom. Same 2 rays, in parallel to the principal axis, out through F. This is tough drawing the line backwards. Oops, I'm going to miss F. Okay, in through C. Should have done this one first, maybe. Back through C. Okay, even if we follow the reflected rays back, they still end up being parallel. They do not cross. No image. Okay, so that's case 4, no image. Case 5 is when the object is between F and the mirror. Okay, so here's my object between F and the mirror. Now all 3 rays are back on as possibilities. So go in parallel to the principal axis and get reflected back through F. I clearly didn't make my little dude big enough. Okay, and maybe I'll go in through C. Go in through C and get reflected back through C. So these guys are not parallel. If you follow them back, they are going to cross back here somewhere. Do the same with the bottom. I don't know why I made my image so tiny. In parallel to the principal axis. I'm going to do in through C first. So in through C. Might need to make my thing longer. In through C, hit the lens, come back, or hit the mirror, come back through C. Making my image longer. Going in parallel to the principal axis. Coming out through F. Whoops, missed F again. Follow them back. And usually when I follow them back, I make dotted lines on this side. Okay, where the pink cross will be the head, where the green cross will be the feet. This is my image. So image is, it's right side up. That means it's virtual. It's larger. It's erect. And it's behind the mirror. Okay, so if we were to look at the progression of the characteristics, sorry, trying to cap my markers here. If we were to look at the progression of the characteristics, in case 1, the object started behind C, and the image ended up being between C and F and was smaller, right? So the object was behind C, the image between C and F, and it was tinier and real. I'm now going to move my object in, and as I move my object in, my image moves out. So when the object is at C, the image from being smaller and between C and F has moved out and gotten larger. So at C, they're the same size. If I keep moving the object in between C and F, the image keeps moving out and getting bigger. Okay? So I keep moving the object in, the image is going to keep moving out, getting bigger, until I get the object at F. And when the object is at F, it's like the turning point. The light rays, and if I did this on the board, they'd be closer to parallel. Sorry about that. The reflected rays end up being parallel. It means they never cross. So at F, there is no image. So now I move the object in further again, move it in further again, and now that it's between C and F, F is the turning point. Now the image becomes virtual and erect, and it's behind the mirror. Now to explain this one, think about the equation. If you think about the mirror equation, 1 over F is equal to 1 over dO plus 1 over dI. If I put the object at F, F and dO are the same thing. So if I'm solving for dI, 1 over dI would equal 1 over F minus 1 over dO, but this side is 0. So 1 over dI equals 0. That would mean that the dI must be infinitely big, because the only way you can divide something into 1 and get 0 is if the denominator is huge. And so there is no image because this is not possible, right? You can't find a distance for dI. Okay? I think the other thing I forgot to say though today, and it would have been in those parallel light rays. Remember when we were finding the focal length? And we said if light rays going in parallel to the principal axis will all cross at a point halfway between C and the mirror, and that point we call the focal length. When we talk about parallel light rays, light from a distant object will always be considered to be parallel. So if you were to take a mirror outside on a sunny day and get the sun's rays to hit the mirror, we would assume that they were all coming in parallel to the principal axis. So light rays from a distant object, like a star, are always considered to come in parallel to the principal axis. Light from a distant object comes in parallel. I think I forgot to say that today. Comes in parallel to the principal axis. Okay? And that will come in handy when we do our lab, because we will use the light rays from the distant star to figure out our F, right? And if you think about it, so 1 over F is equal to 1 over dO plus 1 over dI. If the distant object is far enough away, dO is big enough, this term goes to 0. So then 1 over F is just equal to 1 over dI. So F would be equal to dI. So the image will, for light from a distant object, the image will appear at F because that's where the rays converge. Okay? So that was the pieces that we didn't get to in class today.